This video is going to explain 2012 question number 3. I already have it done, but I'm just going to kind of walk you through it. We have a function f, it's continuous function defined from -4 to 3, whose graph consisting of 3 line segments and a semicircle. The g function is given by g of x equals the integral from 1 to x of f of t dt, and this is f of t, this graph. So the first thing we're asked to do is find the values of g of 2 and g of -2. Well, g of 2, just simply plug a 2 in for x into the function g. So it'll be the integral from 1 to 2 of f of t dt, which means I want to find the area between the curve and the x-axis, the signed area. So from 1 to 2 means I'm going to go from x equals 1 to x equals 2. And the area between the curve and the x-axis would be this little red triangle here. And we have one leg is, it's a right triangle, one leg is 1 unit, and then we have to figure out how long this is. And we get that by the slope of this line is we're going to go over 2 and down 1. So the slope is -1/2. So that means every time I move over 1, I'm going to go down 1/2. So that means this point is 1, -1/2. And so that means that this length is 1/2. So therefore, that's explained down here, but we have the area of the triangle going to be 1 times 1/2 and then half of that. So that'll be 1/4, and the signed area is -1/4 because this area is below the curve. Then g of -2 is going to be from the integral from 1 to -2, which means we're going left. And the best thing to do when you have that situation is just to flip the bounds and make it the opposite of the integral from -2 to 1. So we're going to go from -2 to 1, which means we have this blue triangle plus the semicircle. The blue triangle area has one base, the base is 1, the height is 3, so half of 1 times 3 is 3/2. And the semicircle is going to be half of pi r squared, and so the radius, of course, is 1, so it's going to be half of pi, or pi over 2. And that is an area that's below the curve, so the 3/2 above the curve minus the pi over 2 below the curve will give me g of -2. So on the AP test, this all AP free response questions are worth 9 points. Part A is worth 2. This g of 2 would be worth 1 point, and g of -2 would also be worth 1 point. So for part B, we're supposed to find g prime of -3 and g double prime of -3. So g prime, when you take the derivative of an integral, the derivative g prime of this integral is just simply going to be f of x. So g prime of x equals f of x. So g prime of -3 would be f of -3. So all we do is look, this is my function f of -3. We need to find out what the height of this line segment is right here at -3. Once again, we'll use the slope. The slope, it goes from -4(1) to -2(3), means we're going to go up 2 and over 2, so the slope is 1. So if I'm at -4, if I move over 1, I'm going to go up 1, and that means I'm going to get a y value of 2. So this is -3, 2 is the point. And so since f of -3 is 2, g prime of -3 is 2, because they're the same, so g prime of -3 is 2. And then the second derivative, g double prime, if g prime is f equals f of x, g double prime will equal f prime of x. So if we want g double prime of -3, I need the slope of this line, which we already determined was 1. So that's that. And on part B, it's also worth 2 points, and you'll get 1 point for g prime of -3 and 1 point for g double prime of -3. Part C is worth 3 points, and in part C, we're asked to find the x-coordinate of each point where g will have a horizontal tangent. So there's going to be a horizontal tangent for g when g prime is equal to 0 and g prime equals f of x. So f of x is equal to 0 at -1 and at +1. And we're supposed to identify what kind of critical point this is. Is it a max, a min, or neither? We know there's a max at -1 because g prime, which is equal to f, changes from positive to negative right here at -1. And that's the only one because at +1 it doesn't change sign. So the only max or min, the max at -1, at x equals -1, there's no max or min at x equals +1 because g prime does not change sign. For part C, there are 3 points available. 1 point is for considering that when you're trying to find a horizontal tangent, for considering that g prime of x is equal to 0. And you should write g prime of x, which is equal to f of x, is equal to 0. And of course, f of x is equal to 0 at -1 and at +1. And that is worth 1 point. The next point is for determining the fact that it is at -1 and 1. So you get a point for stating that the horizontal tangents are at -1 and +1. The third point is for the justification. And so justifying that there's a max at -1 because g prime of x, which is equal to f of x, changes sign from positive to negative. And at +1, there is no max or min at x equals 1 because g prime of x, which equals f of x, does not change sign. And so you will get a point for those justifications. And then we go to part D, and there are 2 points available in part D. You are going to get 1 point for the answer, and the answer being that you have inflection points at -2, 0, and 1. The second point is the justification, and that's because g prime changes sign, or I'm sorry, g double prime, which is equal to f prime, changes sign at those places. And that would be all 9 points, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's how they scored this particular problem and how they do a lot of the scoring.